Good morning to everyone. This is my third AWS mini project. In this project, I will design and implement a redundant web server across different AWS regions or data centers. This project involves the deployment of two identical VPCs across distinct data center of AWS regions. Traffic management will be handled by Route 53 utilizing DNS health check to ensure the failover to a secondary server upon detection of failure. Additionally, VPC peering will be established to facilitate the real-time database synchronization between the VPCs. With our primary customer based in Asia, I will deploy our primary web server in Tokyo, Japan, and the backup in Singapore. This strategic placement aims to reduce the latency and ensure optimal website performance for our. This project will utilize the architectural design and network topology developed in my earlier mini project number 2. The only difference on this project is I will be using 10.1.0.0/16 for the Tokyo and 10.2.0.0/16 for Singapore. So after a few minutes, I already finished the deployment of Tokyo VPC. The topology will be look like this, and also I already finished the VPC for Singapore. Before we started, we need to test if our current web server are working. So first we need to check the Tokyo. So as you can see on my screen, I have two browsers are open. One is on Tokyo, one is Singapore. So to check that the web server is working, let's go to EC2, load balancer, and then let's copy the DNS and then paste it in your browser. The load balancer is working on Tokyo region. Test also for the Singapore. Copy the DNS, then paste. The Singapore is working fine as well. First, we need to create an health check. So click on health check on the Route 53, and then create health check. Then we will put a name, endpoint, HTTP, and here for the address, go to your load balancer, select the domain, and then we will paste the DNS of the load balancer, and then create. Okay, next we need to create another health check for the secondary, for the backup. So click domain. So let's go to Singapore load balancer, copy this DNS, and then paste it here, and then create health check. Then we need to go back to the dashboard of the Route 53, go to hosted zone, click our hosted name, create a record. It's a record, an alias. You have to choose the application load balancer, select the region, Tokyo, and then select the load balancer. Then we will select the failover, the health check, primary, Tokyo, failover record is primary, create a record. Then we need to create another record, a record, alias. At this time we will choose Singapore, load balancer, and then the region will be Singapore. Select the load balancer, it's a failover, and the health check will be Singapore, failover will be the secondary, and then create record. So as you can see, we have already created the two records for primary and secondary. Let's go back to the health check, and you can see also there's two healthy health check. Let's copy our website domain name, and then let's try to search on the web. Goes to the first Tokyo region only. I will create a rule on firewall in Tokyo to block all the traffic so that the traffic will move to the backup VPC. So let's do that. On the firewall policy, go to the stateful policy, and then here I will modify the HTTP. Instead of forward, I will drop, save. Also, I will modify this to make sure we have completely blocked all the traffic. So all of the action will be dropped. If you will go back to the health check, it says unhealthy. We will open an incognito, and then I will paste our domain, and then as you can see, it's now going to Singapore. So the traffic is going to Singapore because the primary traffic is blocked. Now let's configure the VPC peering. For example, there's a database at the back end of Tokyo. Wants to update its database on the Singapore, it will be using the internet gateway. But this is inefficient and not secure. So your data is exposed to the internet. The best way to do it is using the VPC peering. So we'll create a VPC peering between Tokyo and Singapore. The connection between this is the AWS backbone, and we will be using only a local route without exposing the data going to the internet. To achieve this, we need to go to the EC2. We will modify the security group. We will add a rule, edit the inbound rules, and then add a rule. So we'll add an ICMP so that for the ICMP, it should be from the other side. 10.2.0.0/16 will be allowed. So, and here on the Singapore also we will modify, edit on bound. So ICMP, it should be from the other side, 10.1.0.0/16, then save the rule. Alright, let's get started. From your VPC on Tokyo, go to the peering connections, create a peering connections. I will name it Tokyo primary. Select the VPC, then we'll select another region. Select the region, which is Singapore, and then we need to copy the VPC ID. So from here, the VPC ID for VPC ID, just copy it and then paste it here. Then create a peering connection. Now the VPC peering is active. Let's go to Tokyo route table. Let's modify this, then click, let's maximize. So let's edit a route, add a route, keep going to 10.2.0.0/16, use peering connection, and in this peering connection, and then save. Then let's go to the Singapore, go to route table, also modify the route number 1, edit route, all maximize, add route 10.1.0.0/16, use VPC peering, and then save. Now let's test. Go to the instance in your Tokyo VPC, like VPC number 1, and then connect, then on Singapore, go to the instances. This is the local IP, so we will ping from Tokyo, ping 10.2.20.154, enter, and then I was able to ping. How about the other side? Let's go to Singapore, open the server number 1, connect, then let's go to Tokyo. What's the IP address? Is the IP address of server number 1, then let's ping 10.1.20.99, ping, and both of them are pinging.